Sarah, this is section 9.1. We're jumping right into chapter 9 after chapter P because this is the chapter on
circles.
Trig. Close. Trigonometry is this section. For those of you who are wanting to take the ACT one more time, you seniors, I do trig next because like everything, like derivatives and calculus and limits and all those things will not show up on the ACT. So this is just one thing that instead of doing it second semester, we do it first semester. So section 9.1 is page 572, 4 through 100 by 4s, and then 106. So lots of vocabulary stuff in this section. Trigonometry, like the literal definition of trigonometry is the measurement of triangles or the study of triangles is what trigonometry is. Angles, we're going to be turning angles into triangles and vice versa and talking about those interchangeably. When you are rotating angles, you should maybe know this. Maybe you trig boys don't already know this, but every single angle that you start to rotate in what's called standard position starts with the initial side of your angle as the positive x-axis, and then it rotates counterclockwise around this way. So this would be like I don't know, how many degrees does that look like? 80 degrees, sure, 80, 75, something like that, maybe. 80-degree angle, okay, it's going to rotate counterclockwise. Now, what happens if it rotates the other direction? Because it can. What if it rotates like down this way?
Then it'd be like 100, 200 some.
How many degrees would that be? Ish.
250.
What?
260.
What?
Negative 110.
What? Negative 110
What?
degrees.
What?
If it rotates clockwise, it is a negative angle. Okay?
You're measuring the other
Now,
way.
if you go the other direction, okay, we're just learning all sorts of stuff already. If you go this direction, that would be how many degrees?
Like a 250,
250 degrees, right? 250 degrees and negative 110 are things called co-terminal
This stuff makes
angles.
It reminds me of last
Co-terminal angles because they have the same stopping place, right? Negative 110 is the same thing as 250 degrees. Those are co-terminal angles. In addition to that, I could say, I don't know, what about 610 degrees? 610 degrees would be the same spot again.
What?
610 degrees would be the same spot again. It would just be, let me get a different color. It would just be around, that's 360, and here's an additional 250. So 610 would also be coterminal because it would end at the same spot, just one more cycle around. Does that make sense? In addition to negative 110, negative 470 degrees would be at the same spot again.
Angle can't be more.
What do you mean?
That's a circle.
I don't care.
What?
Angles can rotate around more than one circle around.
Show me a 360-degree angle.
But we're talking about like angles of rotation. We're
Okay.
talking about like the real life application to angles where it's not just 0 to 360 degrees. You can have a tire that rotates around 720 degrees,
Show me.
which
a
is 2
360
cycles around.
degree.
Okay? And especially when we start to do problems down here where we talk about like angular speed and linear speed. If I cannot go more than 360 degrees, I cannot find the speed of a tire that's going more than one rotation, right? Like I have to be able to do angles that are bigger than 360 if I want to be able to calculate those things, okay? So angles are going to be bigger than 360, smaller than 100 degrees. It just depends on which way you're rotating them, okay? But there's angles, there's initial sides, there's something called a terminal side, which is where it stops. There's co-terminal angles, standard position, all of those are vocabulary words, okay? So the initial side is the starting side that always starts this direction, and then the other one rotates around this way, and this is the terminal side, okay? So initial side versus terminal side, that's what those are. Standard position is so that it always starts in that direction, like this is starting in standard position. Positive angle is counterclockwise, negative angle is clockwise because it's going down first. And then co-terminal angles, okay? So 50 degrees and 410 degrees are the same. So if those are co-terminal angles, what's the trick?
360.
You just add 360 each time, right? Like if I added another 360 onto 410, that would be 770 degrees, would be another co-terminal angle. These are all co-terminal. They end at the same spot. If I subtract 360, do you know how much that is?
Negative 1 or 310.
Negative 310. Negative 310 degrees, okay? I'm subtracting 360. How many coterminal angles are there?
Infinite?
Infinite. You could keep going forever and ever and ever. You're just adding another circle or subtracting a circle. Does that make sense? These are coterminal angles, okay? Now, they also talk about 0 and 2 pi are coterminal angles. These are in what's called radians. We're going to get to that here in a second. This is radian measure. This is degree measure, which is what we are used to seeing, okay? These are radians also, and these are radians also. Radians and radians, okay? All right, so we are not thinking yet in radian version yet, but we know our degrees, hopefully know our degree measures pretty well. Yes, sir.
How come we decided that there was 360 degrees in like a circle? And how come
I don't know. That's a good question. I don't know. It's something to, I don't know. I agree with you. I don't know why we did that.
Lose 365
Yeah, I don't know why. I don't know why it's 360. Good question. I would have picked like 100
Because
if we were being.
the sun goes
I don't know.
around
Okay.
and it has 5 days.
All right, are you ready for this? This is the hard part. So I need your full and undivided attention for the next like 3.5 minutes while I explain this bottom part here. Ready? And this is stuff that's really good review for you people who took trig last year. Here you go. This is the definition of a radian. Okay? A radian. Our brains don't think in terms of radian, but here is what a radian is. Let's look at this circle. This is a radius. R-A-D-I-U-S, right? Okay? All right, so if I take that length, whatever length this is from here to here, and I strap it from here to here instead, this measure right here, that number of degrees or whatever, is the measure of what one radius is, right? That's what one radian is, or one radius length. So it's like saying the distance from here to here, make that the same distance from here to here, and you have 1 radian angle. That's what 1 radian is. Okay, let me explain that again. So 1 radius goes from here to here. This is the radius of my circle, right? If I then rotate that and I say we're going to start that here and we're going to rotate it up this way so that this is the same measure. Maybe this is 7 units long, 7 inches right here from here to here. I'm going to make this 7 inches also, right?
Oh,
the
so-
angle that is represented by that is called 1 radian.
So it's like an equilateral triangle, but with an
Kind of.
bit.
Kind of, right. That is 1 radian, okay? 1 radian. Now, if we're talking about in terms of a circle, how many radians are there in a circle? Like if I would do that again, I would probably land somewhere over here, right? Okay, I would probably land somewhere right here. That's another 7 and 7, and another 7 would be like here, and another 7 inches would be like, I don't know, here, and another 7 would be like here. I'm not marking these out very well. Okay? No, it does not depend on how big your radius is.
Because the circle gets bigger.
Because the circle gets bigger the larger the radius is. So it does not matter if it's 7, it doesn't matter if it's 100, those lengths will be the same. Do you know how many there is? Now hold on. Wait a second. How many radians are there in a circle?
7, 8.
No.
7.
1, 2, 3, 4, 5, 6, and my units aren't very well good. This one needs shifted over a little bit. This one would be right here, and this one would be right like here-ish. And this is 0.28. And let me show you how I know that.
Change.
No, that's
6 and
6.28.
6 and change.
This is right here in this first half of the circle is 3.14
Oh.
radians.
What?
What?
Pi is everywhere.
Pi is everywhere. There are 3.14 radius lengths from 0 to 180 degrees. There are 6.28 or double that all the way around to 360. If I take those radius lengths, there are 6.28 of them all the way around the circle, right? There's just one chunk that's left over. Does that make sense? So 360 degrees is equivalent to 2 pi. 2 pi radians, okay? Here are my units. This is in degrees, this is in radians. So 360 is equivalent to 2 pi radians because there's 6.28 radius lengths in a circle. That has to do with circumference. Circumference of a circle is 2 pi r. That's how you find circumference of a circle. That is equivalent to 360 degrees. If we're finding the length all the way around, that's circumference. That's 2 pi r. That's equivalent to 360 degrees. Okay? What would 180 degrees be equivalent to?
1 pi r radians.
1 pi r, right? We
1
said
pi r.
3.14 of them were from here to here. That's 3.14. Okay? Whereas 180 degrees is kind of representing the degree of the angle, the 3.14 is kind of representing the arc length, right? The length of that arc that is there, right? Okay? So there are 6.28 arc lengths going all the way around that are the same measure as the radius, if that makes sense, okay? So since 2 pi is equivalent to 6.28, there are just over 6 radius lengths in a full circle. Here's the first one.
Why do we say
Here's the second one. Here's the third one. Here's the 1, 4, but if I do this is a fourth one, fifth one, sixth one, and then this is 0.28. Okay, kind of like what we had before.
Like a
Why do we
radiation
say
circle.
pi is 3.14 and not 6.28?
Because 2 pi is 6.28.
I know, but
Why
take
did-
away the 2.
Yeah, I know. I don't know.
Makes 0 sense.
For triangles and such.
Because it has to do with like circles. So pi is a naturally occurring number that has to do with circles, and they have found that the circumference around the circle, whatever that is.
8, 7, 9, 4, 6, 7, 7.
Answer it.
No, that's American Red Cross. I'm pretty sure.
Answer it.
No, don't answer it. Put it away.
Luke.
So they have just found that whatever the radius is, you take 2 times pi times whatever that radius is, and it gives you the circumference of a circle.
Why don't we take
So you're saying, okay, why don't we just say that their circumference is just pi times the radius, right? And like this is really like the 2, right? Okay, then our area equation, instead of being pi r squared, it would be like
Half pi.
r squared, what r divided by 2 squared pi. It would be a mess. Yeah, so that would screw up the area formula. So they've just made it easy on us, and they've done pi and 2 pi, all that good stuff. So anyway, there's that. Okay, so when you're converting between the two, go to here. Go to the example on the next page. We're skipping a bunch, but we'll come back to it. Okay, example on the next page. So if I am applying a conversion, here is the deal. We said that 360 degrees is equivalent to 2 pi r, right? 2 pi radians. Okay, so 360 is the same as 2 pi. That means that 180 is equivalent to just pi radians. Okay, so when we're converting, we either say 180 degrees over pi radians, or we say pi radians over 180 degrees, because that's what they're equivalent to. So like on this first one, 135 degrees, I'm going to put it over 1, and I'm going to convert. Do I want to use pi over 180 or 180 over pi?
Pi over 180.
Pi over 180, because I want the degrees on the bottom to cancel. Okay, I want this degree to cancel with this degree, and then all I do is reduce, and you do not come up with a decimal. You reduce it as far as you can. So I know I can divide by 5. This is 45, and this is 27. But then I can divide by 3. No, I can divide by 9. This is 3 pi over 5, I think. 3 pi over 5 radians is what we have. 3 pi over 5 radians. Good? Make sense?
Wait, hold
Wait,
up.
wait. So
Hold-
you-
hold up.
If it's
We could have
bigger-
just reduced by like 45 to start with.
If it's bigger than 180, do you have to use the 2 pi, or can you still use the 180?
You can still use pi over 180 and 180 over pi. So like number 2, this is 270 over 1 times pi over 180. And then I reduce. I know that both of those numbers are divisible by 90. Okay, so this would be 2, and that's negative 270, so it's negative 3.
2
So
pi,
this is negative 3 pi over
2.
2. That's what it is.
But then you tack on the radians at the end.
Yeah,
Right.
radians, yeah.
So when you're doing the equation,
We get really lazy.
The R doesn't mean anything.
Right,
The R is just a label.
right. The R's, the radians is the label for it. Okay, all right, let's stop there because we're going to run out of time. We will reconvene tomorrow.